Hey, how's it going? My name is Luke Stokes with eosDAC, and I want to get a little bit geeky with this video. So this is going to be quite technical, not going to be for everybody, but I think it's important when we talk about blockchains and the promise of blockchains and what we can get from global nonviolent consensus. This way that we can provably look at the code, look at the transactions, have this transparency and interoperability on a blockchain, and in a way that everyone can agree that everything happened the way we think it happened. So it's really important when you're building smart contracts to have this code itself actually live out there on the blockchain in a way that we can all agree on what it's actually doing. This is kind of one of the foundational concepts of a DAC, a decentralized autonomous community, is that it's built in these smart contracts out on a blockchain so that there's kind of a provable system of trust. Certain inputs go in, certain outputs come out, and everyone expects the same thing. There's no surprises. There's no confusion about how the system is designed to work. Now, the only way for that to actually happen in real life is for people to actually review the code that is out there on the blockchain and to understand it at some level. And obviously that's pretty complicated. Not everybody's a programmer. Not everyone can do that. As programs get more and more complex, that gets even harder. Very few people actually compile their own source code when they run an application, especially even though they should. Like applications that deal with your private keys on a blockchain, for example, you should be really careful that there isn't some code in there that says, hey, transfer all my tokens to somebody else. So this is one of the reasons with eosDAC, we're building all these individual smart contracts that are pretty small and can be reviewed pretty easily to understand them and understand what they do. And from that standpoint, whenever a change is made to that code, it should be pretty easy to review that change and to kind of make sure it does what you think it should do. And this is something I really want to stress within the EOS community. There's more and more contracts out there that are just controlled by one person, which is a very, very dangerous situation. Essentially, whoever gets access to those private keys can modify those contracts at any time and then change how that contract works. So if you're using any kind of application on EOS, you really should know that you can trust the application that you're running, the code you're running. And the nice thing, again, about a blockchain is you can go and review that code directly if it's an open source project. You can verify that what's on the GitHub actually matches what's running on the blockchain. So what I'm going to run through today is like an example of how eosDAC does this on a practical basis. So we have right here, I want to show you, we have this DAC multisigs bit of code, and this is something we've been working on. This here will kind of, it's pretty straightforward. It's kind of for proposing and approving and unapproving, canceling, executing multi-signature transactions within the context of the DAC. It's very similar to the eosIO multisig. And the reason we want to be able to do this is that so we can keep track of the metadata. So the custodians that are going to be running the DAC can kind of come in and say, what do I need to approve? What pending transactions are out there, pending configuration updates or code updates. And by distributing it through multi-signature permissions, each person that is in charge of the DAC, becomes not a single person, not a single point of failure. And we see that a lot with systems again today that are just controlled by one person. Whoever has that private key controls the entire system, all the funds, all the different things that contract does. So it's really important that we start more and more decentralizing these systems for higher security. And this is, again, a reason why I'm really excited about being involved in the eosDAC block producer, because we're a community-owned block producer. We have a distributed mechanism for managing the system. So we've got some code that's got to be pushed out here. And if I'll show you here the multi-signature transaction that's ready to be signed and approved, you can see here it's pretty confusing. You can look at this data and it's not very user-friendly, right? It's a bunch of hex code, and it's like, well, who knows what that code is going to do, right? It's very difficult to go from this pretty clean code on GitHub that we're trying to push out. Basically, it's a set code for the compiled version of this here to this. It's like, how do we bridge that gap? How do we figure out what's actually going on? So I'm going to walk through that. It's going to take a little bit of time. It's going to be a little bit long, but it'll be hopefully interesting for the technical geeky people that care about this stuff. So first off, I want to just kind of talk about my environment. So I've got this set up right now, this Clio script, which is pretty straightforward. It just basically means I don't have to put in the URL, and it kind of defines where my Clios is. You don't have to use that, but that's just something I'm using. Also, this will require the ABI from hex binary, which is important, and I mentioned that here. You can get that from this patch, which is listed here, and the code for it is down here. It basically just takes that hex and actually takes the binary and kind of gives you something meaningful that you can work with. And the way to do that is you basically just add these lines to your make file, and you go ahead and compile it, and you'll get this new binary out there. So we'll be using that. If you don't have that set up, then you'll have to do that first before this will make any sense. Also have JQ installed. It's just a nice little tool set for working with JSON. It's really simple, easy to use. It's a command line JSON processor, very, very helpful. So we're going to be using that as well. Okay, so one of the things to point out is it's really important, whatever version we're looking at, that we actually use the exact same compiler. So when Michael Yates compiled this particular one we're looking at today, he used the CDT version 1.3.2. So a way to get that is to clone the repo and go ahead and check out that specific tag and then just build from source. I normally would have used like brew install, but that installed the latest version, which we're still using 1.3 for this. And we'll be upgrading soon. But it's just important, if you're wondering why you're not getting the right outputs when you go through this process, to check that you have the right compiler version. And again, I should probably back up. What we're actually doing here is we want to confirm that this gobbledygook code here is exactly what we expect from this actual GitHub repo, this code here. This is a way we can validate and verify that the code we're running on our blockchain to run our DAC is accurate. So once we got that all going, we go ahead and run EOS IOCPP, and we actually compile it into the WASM file. And that also outputs the ABI file. So let's go ahead and do that. Actually, first I'll need to be in the right directory here. I've got these kind of set up, as you can see. So we go ahead and compile that. And now, once that's done, we should have two different, that's the ABI file, and we've got the WASM file as well. So there's the WASM file there. So now that we've got that, we want to go ahead and get the SHA-256, and this basically checks every single character. Like if a single character was to change within that compiled file, then this would be a completely different hash. You guys know about that as far as hashes. So it's a way that we can verify what's actually going on is what we expect. So then this long crazy command here, what this does here, and I'll break this down just a little bit. First, we can just grab the code that we want. I'll go back to my folder here. So this right here is just a bit of code. That output there is just the code in that format. And then we can run it through this XXD, and that gives us more kind of the binary code, and then we can check that. And lo and behold, we get the same hash, which is great. So that basically tells us that the code itself, the actual compiled code, is what we expect. The next thing we want to check is the ABI. And the way we do that here is we just run this through JQ, through the ABI from hex. So here I'll actually do that in steps here. So first we grab the API. So here's just the ABI. And then we run that through the eosDAC from hex little tool we have. So I've got that in a little separate folder, but it's pretty straightforward. And so there we go. So there's the actual ABI off of the blockchain. This is actually querying that multi-signature off the blockchain. And then we can actually finish this up with cleaning it up and saving it to a file. So now we've got that saved to a file. We can actually cut that out. You can take a look at it. And there it is. So now we want to compare that with what we have actually in GitHub. So I've already grabbed the Multisig GitHub ABI, and we actually just regenerated it as well. And then we can run that right there. So this comment is auto-generated. We don't have to worry about that so much. I also noticed a couple things where the keys are just in a little bit different alignment. So like types shows up in one place, and it's different in another place. Also, in some versions, you might have these error messages and variants. You can see they're just empty arrays anyway. So it doesn't really matter. The key point is here that the kind of the signature of the code that we're pushing out, the ABI for that, is the same. And so that's essentially it. That's how you can go through and look at code that exists on GitHub here, and then look at code that exists in a multi-signature transaction that you're supposed to be approving. And then from that, basically decide, okay, is this actually the code that I want to push out? And so the reason why I wanted to do this video is this kind of stuff is not important just for block producers, because block producers have to do this as we are making system contract updates on EOS IO, but also it's important for eventually for DACs and DAC custodians, because anyone who's part of a multi-signature permission system for managing applications on EOS, and hopefully again, this should be more and more people. This should become more and more common as we start thinking about ways to protect our code. We want to take those permissions and distribute them to multiple people so you don't have a single point of failure. And so we have multiple people involved. You can't just like push out the code whenever you want. You have to put it in a multi-signature transaction. And so when you go ahead and do that, you have to have a mechanism for people to verify that that multi-signature transaction is the code you expect it to be. So walking through this process hopefully is helpful for other people in the future to recognize how to actually do that. And you could tell it was a little bit of command line stuff. It's a little bit confusing at first and a little bit crazy. I've done this a few times now, so I'm starting to get a little more comfortable with it. Hopefully in the future we'll have tools to make this even easier. But for now, this is what we have. This is the process. And this is something I think is important. If we think we can set up systems of governance that are not needing threats of violence, for example, in order to come about consensus, then we have to take responsibility for these systems and this code. And part of that process is being educated, being aware, taking actual personal responsibility to validating what we think it is that's out there that's running on the blockchain. So hopefully that was somewhat useful, at least interesting. And so if you have any questions, definitely leave comments in the video and let me know what you think. I really hope more and more application developers and systems being built on EOS will start taking security seriously when it comes to who manages their system contracts, because most of the hacks you hear about in the Ethereum and EOS space are mismanagement of private keys. They're not always just the code being hacked, but sometimes it's the code being hacked as well, or a bug in the code. And this is a way that we can actually have multiple people reviewing the code and managing permissions in order to ensure what we have running on a blockchain is as secure as we can make it. So again, hopefully that was helpful. Let me know if you have any questions, and take care.